Thank you all for joining. Today's topic is going to be open source software solutions. We are going to be focusing more on mobile communication system related open source software projects, but we'll also touch upon a couple of others. For example, there is one related to AI ML that's ongoing, hot. So wanted to touch upon that also. So let's get going. Since we are from Intel, we are required to put up this notice and disclaimers so that these are training purposes is explicitly communicated to the audience. And then those who have attended the previous lectures might have heard this message, but I'd like to quickly repeat this. Intel maintains a website called networkbuilders.intel.com. This is free for anyone to access and use. So it is not to promote just Intel technology, but to encourage learning in the computer science, chip technology area. It has about 400 courses students can take that are categorized into different sections, categories. And so each one is taught by a subject matter expert from Intel. And it's only like 1 or 2 hours long with a short quiz at the end. Once you complete, you get a check mark that you have completed that particular course. And there are what are called custom pathways. In case, let's say, instead of doing just 1-2 hour course, you are interested in some particular area, let's say AI ML, mobile communication, or security on the internet, things like that. We have these custom pathways where multiple courses are strung together to form one chain. So you can complete that and get certified as well. Intel does not want to charge any money for this service. It's all free. But if you do want some sort of a digital badge that you can put on your LinkedIn profile, anything like the same courses are offered via Coursera. And then there you can pay, I think, a small fee, after which they'll give you a digital badge that can be attached to your digital profile, right? So please do take advantage of it. If you have feedback, some course looks good or doesn't look good or something is confusing, please provide feedback. You can send it to me. You can put it up on the site itself and spread the word so people can benefit from it. So today, what is the agenda? So we are going to talk about first, what is open source? So there is a lot of confusion. People often think open source, so that means free software, right? Things like that. So we will clarify what is open source exactly. We will get into, actually, we'll go into these projects specifically first. ORAN, DPDK, OpenVINO, those are open source projects that are there. Then we'll also talk about different licenses and business models that exist. There may also be a perception that once you put something in the open world, then you are done and then things just grow on its own, etc. So there are a lot of nuances as to how these projects are managed and how one can get involved. How do you contribute? How do you make use of it? What are the responsibilities that come with it? So we'll discuss those in the middle section. In the end, I do want to provide some key takeaways so that at the end of the lecture, you have some clear idea of like what is it that we discussed, and you have a clear actionable items and intelligence that you can go to get involved in the projects that interest you. Right? I wonder if you all know who this person is. He is actually known for this particular quote that says, any sufficiently advanced technology is indistinguishable from magic, right? So the idea is, if you bring someone, let's say from 100 years back, suddenly transport them to today's technology, what they are looking at from, like, say, even a simple TV remote control to how using a phone you can talk to someone on the other side of the earth and you can see their picture, it'll all be like magic, right? They won't understand how it's happening, and it may look miraculous. The person who said that is actually Arthur C. Clarke. Many of you may know him. He's a famous author, writer, and in fact, the geostationary orbit, 36,000 kilometers above the Earth, where satellite, if they keep spinning around. It basically stays at the same point above the Earth. That was originally proposed by Clark, so it's actually called Flirt's orbit. So he is not just a fiction writer, but a serious idea generator who has written about phenomenal things. So why am I starting with this quote? Is because I just want to show you a short video. So let me play that video for you. Let me make this full screen. The sound is included, so hopefully you can hear the audio. This is my daughter. Then I went to a nearby parking lot and then I recorded this video just for this lecture just last weekend. So let me play the video. It's only just like a minute long. This is my daughter. Our red Tesla Model 3 is standing there. We are just in a parking lot. Imagine you are just out of a restaurant and it's really raining. So instead of walking in the rain, you can use the come to me feature to summon the Tesla. You can see on its own it's backing up, reversing. It does it very, very cautiously. So it's not like running over any of the parking spots. It put the turn indicator. You can see the steering wheel turning one way or the other. Yeah, you can stop. Yep. So you can see there is no human being. The car reached us. That's a miracle of open source software. That's what I wanted to convey, right? So I'm sure you have seen videos like that on the web that is showing Tesla full self-driving feature and so forth. But if you really think about it, the phone that we are using is using the Android operating system. That's one of the open source projects that are out there. And then not only the Android operating system itself, but on top of that, even the Tesla software is all written based on Linux. And Linux is the biggest open source software that's out there. So what appears like magic, I mean, even to us, 20, 30 years back, if somebody says, oh, you are call the car and it will just come to you, it may look like major science fiction, but today it's possible, right? And you can see the car is a little hesitant in coming over. That's mainly because I put that in that kind of a mode, just not to rush. Tesla offers a more aggressive mode. If you put it on, it might even move and come to you faster. So even those things are configurable. But this is becoming possible only because of open source software being there, right? Of course, in theory, this could have been done using closed source software also. But in general, the speed and the development and the volume of development that goes on cannot be this high. Basically, it cannot scale if everything is in closed source form, right? That's why I wanted to start with that little video. So let's dive into it. So what is open source versus what is closed source, right? The main thing to remember is if it's open source, as the term explains, the source code of that particular software is visible to you. It's available to you. You can examine, you can look at it, right? So that's the distinguishing feature between open source and closed source. But if it is open source, it doesn't automatically mean it's free, right? So this is something we need to keep in mind, because often we think once you put something in the open source, then you can no longer make money off of it. And so why would somebody do it, kind of thing. Of course, there are a lot of good societal reasons. If it's open source, a lot more people can use it. It's free of cost. Anybody, whether they are in US or India or any part of the world, they can get good quality software and they can use it. All that is there. But if nobody can make a living off of it, then it may not be practical to write a lot of open source software. So want you to be aware that software could be open source, meaning the source code is visible for you to inspect and use, but you may still need to pay for it. That model is fully allowed, right? And there are so many different kinds of licenses that are available within the system, one versus the other, and we'll look at it towards the end of the lecture. And that does allow you to make money, make a living off of creating open source software. Okay. So just a bit about open source, meaning, is it just some hobby project by some few people, or how big is it, right? If you really look at it, the biggest open source project in the world, I think, is easily the Linux Foundation, that I'm sure you are all aware of. So in that has published this data saying there are actually 40 million developers around the world that work on open source software development. Then 2.9 million companies and organizations that are involved in various, not just the Linux open source thing alone, but all different kinds of open source projects around the world, right? And there are this LOC lines of code that are modified is 3.6 million lines per day. Okay. And there are so many bills that get generated. There are so many projects that are created. So this is not anything small, right? So this is worldwide. Anybody can get involved. There are tons and tons of people really working on it. And so this is a massive effort, but spread across so many different projects all over, between commercial entities like Intel and totally non-profit entities like Linux Foundation, that all come together to make this possible, right? So in general, you know about Linux. So originally created as a small little operating system with the kernel that was put in the open source, that's bloomed into something really gigantic today. So Linux certainly led the way to this idea. Of course, there were in parallel a lot of other things also that were open source and projects that were going on since the 80s and 90s. But Linux was the most prominent one that made the model highly visible, showed that it's plausible, meaning theoretically, practically, it's a model in which people can work. It can generate a lot of value, and people can make a living off of it. That idea was brought to life by the Linux thing, but there are so many different projects all over that are open source, right? So that's out there. So now, in some way, we can say that is the de facto development practice of today. You can certainly see there are huge companies like Apple, their iOS is closed source, meaning you cannot get the source code of iOS and then do anything on your own. Similarly, Windows is closed source. So that may come up as two really big software companies that we work with, and the source is closed. That's true. But as we keep diving in, I'm going to talk mainly about 2-3 projects that are close to mobile communication. But you can, once you start digging around, you will realize how big this open source world is. And I mean, you and I can go start a new open source project today, right? So it's easy to start, and so it's mushrooming really big. And a lot of companies are slowly realizing that this is a model that helps you accelerate really fast in whatever that you are trying to do, if it is structured correctly, right? So it's gaining momentum, not slowing down anywhere at this time. So there are these impressive statistics. Look at all these. None of this is less than 70%, right? So about 70% of the education sector uses Linux via Chromebooks. So 96% of the top 1 million domains in the world are run by Linux servers. So there are, of course, Mac or Windows operating system based servers, but as you would know, pretty much the entire world runs on Linux based web server models, right? So many of the workloads. So this is Amazon's web services in which you can get a machine virtually and then start running workloads. So they assess and then compare how many of their workloads are really running on standard Linux. So that alone is like 92%, meaning almost all the work that gets done on the Amazon cloud seems to be running on Linux, right? So, and you can go on and on. The combined smartphone and tablet market, this is via Android. So the remaining maybe iPhones and other small variations that are in Europe, but the most dominant version we all know is Android-based ones, which is about 70% of the world's smartphone. And most of the supercomputers, I mean, Intel works with many national labs. You can go check out, look up Argonne National Labs, Borealis, Aurora, AURORA. Aurora is the name of the supercomputer that's built in Chicago. We are still working with them. Building a supercomputer takes a lot more time than just few months. So more than half the computer is done, and Intel is providing chips to that particular project. Even those, the world's best, top, biggest supercomputers, etc., run on Linux, right? So that goes to show how trustworthy open source software has become, how big and powerful it is, and how mission critical software, not only at the individual cell phone level, but at the world national level, can all run on open source software, right? So it goes to show how well this is blooming. Intel does participate at all levels of the stack. By this, we mean at a really low end, at the chip level, at the individual firmware level, or maybe at the individual operating system level, kernel, etc., all the way up to the latest application in Python, those kinds of things that I'm sure you know. So we do contribute, we do work on all these areas. So some of these, for example, are MPEG codec, meaning how to play video, those kinds of standards. So we do contribute. So there's a large number of Intel engineers who are purely working on software, and then they do work on all these kinds of projects. So this just gives a sample of different stack levels, at the lowermost at the chip level, all the way up to the application level, AI and different domains, etc. Right? So we are fully involved. Even whatever my own team develops, so we develop a lot of driver software that I had talked about in the previous lectures for example, DLB, Dynamic Load Balancer. That's one accelerator that is in the Xeon devices. The software that we develop, we do put it out as open source, meaning we put the source out, anybody can look at it, so there is nothing hidden. But it's not open source like, say, Linux Foundation, because we are not constantly accepting submissions from the world to make the software different or better or improving. We actually do all the work continuously, but we open source it. We put the code out there. So if you want, you can take it, make improvements, use it yourself. If you want to tell us what you did, that's great. But the model is generally we do all the work, and then we give you the source. You can do whatever you want with it. So many of the other stacks that we develop, that is also in that model, meaning Intel does all the work, but we give you the source, so it's effectively open source. And again, it could be, just to go back to that, open source doesn't mean free, right? So some customers that we work with, we do development and then we give them the source, but in some cases we do charge money for it, because it's more like a contract job that we did, and we have given them the source. They of course make changes, they make improvements, integrate it in their system, write the application, but they do pay us for the code that we have delivered. So open source doesn't mean free, but generally the source code is available for anyone to look at and use and improve. Okay. So before we dive into the individual projects and how they work, etc., how do you get involved? What is, if as a student, as a faculty, as an individual citizen, if you are interested in getting into the open source world, what do you do? Right? So the process is generally you start with learning. So whichever area that you are interested in, let's say you are interested in the Linux kernel, or you are interested in AI, ML related areas. So you can first go learn about the ongoing OS project. What is going on? So what is it that I can I mean, what is the current status and where people are contributing, and what is the next big goal that people are working towards? And once you make sure that it sounds interesting, that is something that you would like to be involved in, you can become a user. And we will go through the specific projects. But if it's Linux, right? So you may have a Windows PC at home, maybe an old laptop. You can try converting that into a Linux PC. So how do you go about doing that? You can pick and choose the right kind of Linux distro, meaning the distribution that you would like to work with. For example, Ubuntu or Red Hat, these are really popular distros a lot of people use. So you can just go download that software. Depending upon the licenses that we will talk in the end, many of these Linux distros are free for you to download and use. And year after year, these things are becoming better and better, meaning how do you download, how do you install, how do you configure any given machine to work well. This is all becoming easier by the day, right? So I have tried installing, for example, Linux 25 years back. At the time, I struggled for like a week to get a dial-up modem to connect and then make a dial-up call. Whereas within Windows, it was much easier and it was much more difficult. I was getting frustrated. But today in our labs, we use Linux left, right, and center. And all the work that we carry out are all in various Linux distros. We do support, my team supports multiple Linux variations. And installing one in any system is a breeze now. You can just download a small piece of code, click on it, trigger, and then it actually will download the rest of it. Figure out what kind of machine you have, what chips, what network card you have, what graphics card you have, and configure everything up and running, and then you will have a Linux machine pretty quickly, right? And you can, of course, also make it dual boot. You can have Windows plus Linux or whatever combination that you are looking for. And this is just, I'm just talking Linux as one simple example. But once you have that machine, whether it's Windows or Linux, there are so many other software projects. Let's say your interest is in video. So there are video related open source projects you can download, install, and play around and see how good or how bad that is. So becoming a user will give you more knowledge into the details of how it is set up, what is it expecting, how the approach is, etc. And once you become a comfortable user, then you can consider becoming a reviewer. So each one of these open source project, if you go to their website, they'll always say get involved. There should generally be a link equivalent to that. So if you click on it, you can get on their mailing list, and then usually you can start reviewing the submissions. So we can again go back to Linux because that's one of the gargantuan project that's out there. So my own engineers, they are subscribed to the Linux open source mailing list. And so the code that people submit, they all go into GitHub. And then depending upon within Linux, what area you are interested in, right? So maybe you are in memory optimization, or maybe you are in network interface, part of the Linux operating system. So I mean, since Linux is so big, there are so many different divisions within that. So you can choose an area that you are interested in, subscribe to that list, then you will start seeing all the code that are being submitted to be accepted and to become part of the Linux kernel, to become part of the Linux distribution in the future. And so there is always a need for more and more reviewers to come in, review the code, and provide feedback. And as you start doing it, of course, you are going to see what others, more experienced reviewers are saying, so that you can look at it and then provide feedback in a similar way, so that the code acceptance continues to improve. You get better and better submissions coming in, reviewed promptly, and then get accepted into the next release. Right? So you can become a reviewer. So that's the next step after being a user. And after that, you are a software developer, you really want to really dive into it, then you can start contributing. So my team and Intel is really big in open source contribution. So we do develop a lot of new technologies, ideas, ways to improve existing things. So for example, let's say packets flow through the Linux operating system. So Intel came up with a model called XDP. You can look it up. So how you can speed up the packet transfer through the kernel. So that's an idea. So you write a story, you submit, get the community to review, and then accept, saying, okay, yeah, this kind of makes sense. Maybe you guys can develop the code and submit. Then you actually fork out a copy of the Linux code. Then you start developing the model that you are talking about. And there are a lot of details as to how you write the code, how you structure it, what is the format to follow, how you should comment it, what license and what title information that you need to put in, and so forth. Once you do that, you test it out properly locally on your system. Then once you are convinced that it's all working okay, you basically submit it to the Git repo. And once it's on, it's all highly automated. So once the check-in gets completed, people that we talked about in the previous level, right, the reviewers, they all get notified saying there is a new submission. Then they come in and then look at your code and provide feedback. Of course, getting things accepted into the core of Linux is really difficult now because the quality has improved so much and there are so many people contributing to it, which is good, and the quality continues to improve. But you can still go in and see. So for example, let's say you work for a small company that has developed a new NIC card, right? The Network Interface Connect, the network card that you plug in. And so there is a specific driver that is needed for the NIC card to be recognized by the kernel driver. I hope what I'm saying makes sense. So your eventual goal is your ABC company's new network card. It is on, let's say, a PC, and then you put Linux on it. And so when the Linux boots up, we want us to automatically see, hey, I know this ABC company NIC card. So it immediately recognizes and sets up so that if you connect a wire and then start pumping traffic, it will start flowing, right? If it is not able to recognize, of course, then you need to provide the driver for that NIC card separately, as I don't know how, maybe in a USB stick, or you put it on a website and people download and then put it into their PC, run it, and then the driver gets added to the operating system there. Then it starts to recognize. If you do that, it is called out of tree, meaning in tree is what comes with the Linux or the whatever open source distribution itself. If it's not there, and then you need to get this function added separately, it's called out of tree. So Intel works in both models. Ideally, if you develop a new NIC card, we do want to provide the driver to the Linux community well in time to get it reviewed, get it integrated into the Linux kernel, and then it becomes part of the Red Hat or Ubuntu or BSD Linux, whatever that may be out there. And so when things are loaded onto a PC, it automatically can recognize the Intel NIC card that is in the system. And of course, it's not limited to Intel only. Any other network card that you can think of, all these companies write the drivers and submit it to the Linux open source project, right? So once it gets submitted, then this can immediately be recognized. But let's say you already got the card out, you submitted, but it's still not been accepted, then the card cannot be recognized and used. In that case, you provide an out-of-tree driver. So even the DLB that I talked about, it's not a NIC card. It's more like a silicon acceleration engine that is within the Xeon processor, for which we do provide out-of-tree driver because it's not been quote-unquote upstreamed, meaning submitted to the foundation for it to get accepted and become part of the Linux kernel, right? So maybe rambling on for a long time, but I hope what I'm saying makes sense. You start to contribute by taking a copy of the existing open source, adding to it or modifying the code to make it better in some way, maybe recognize something new, maybe add a new functionality, and then you submit it back to the community. And that's what contribute means, right? And once you become really comfortable with that, I mean, all these things probably takes years, right? So nobody joins an open source project that's been well established out there for a long time and then become a major contributor in 2 days. It takes time. Again, depends on how mature the project is. So if you take Linux Foundation or something, it will take time. But if it's a new project you and your friend had set up yesterday, of course, people can start to contribute quickly if they understand what's being done. And once you continue in this role for a long time, you develop community credibility, right? Everybody in the community comes to know, hey, this person, he or she has been around for a long time. They work relentlessly. They provide a lot of good reviews. They promptly review and provide very useful feedback for the people who submit the code. They've been contributing very well for this project, etc. So at some point, then you can become a committer, moderator, or you can become a starter. What we mean by that is once somebody contributes a code, there will be somebody in the open source project who will basically commit, meaning approve it fully and then get the code committed to the source that's out there. Then it becomes tested, it becomes part of the next release, right? Or you may become a moderator, meaning when things come in, let's say somebody proposes a new idea, you are sort of like a demigod, right? So you are sitting there and you are so well experienced. Then you will be the person questioning, you are the gatekeeper, saying, is it really adding value to this particular project? And why are they doing it? And is there going to be some malware coming in? Or is it opening up some vulnerability to the code, etc.? So you become a moderator, you question, you accept, and then maybe they submit a new idea, you say, okay, yeah, this makes sense, and then go ahead and submit the code, that sort of thing. And you can also become a starter in the sense you can say, I want to start this new project within the big open source area. Like I said, Linux Foundation was a huge one. Intel started something called XTP to speed up the packet flow through the kernel, right? So you may want to start something like that. Or you may actually start your own totally independent, different project as well, right? So that's also possible. Remember, even Linux, whatever, 30 years back, 40 years back, was started as a small project that's really bloomed into something really, really big. So something you start tomorrow may become a huge project 40 years later. So everything is possible. And it doesn't cost that much, right? You basically just write the code that you think is useful, put it out on GitHub, give it a name, and then call it the project, choose a particular license saying, what do you expect people to do? How should they use it? Do they need to pay you, or can they just copy and use it? We'll talk about various license model towards the end. So you define it, then it becomes a project and you can get going. Right? So this is the normal flow. Learn about it, become a user, become a reviewer, then you start to contribute, then you become a committed moderator, or you start your own project, right? So that's the flow in which things work. So now coming towards more mobile communication, I think I showed this slide even in my previous talk on the 5G. So where are we? Particularly my team, where are we working? Is mainly on this base station area, right? Intel does have a lot of products in the core CPU side also. So we do sell chips for the core network, for the data center, and so forth. This NEX that I belong to, that networking and edge division, it basically generates develops devices for basically cell tower, right? So we sell these chips to equipment makers that make cell tower equipment. And then they design the board, design the system, test it, make sure it all works okay. And then they hand it over to companies like Reliance, who actually put it on cell tower and provide the service, right? So within that, I show this slide just to say, whenever we say chips, whenever we say data center, anything like that, people immediately visualize something like a nice air-conditioned room in which chip is sitting there working. But that's not true always, right? So we make chips in for cell towers that can, this is taken in Sweden, that can be completely iced up to cell towers in Arizona that is baking in really hot sun temperature. And this is just on the cell tower side. Intel also makes chips that is used in industrial automation, etc. So it may really get cooked up to like 105 degrees Celsius. I'm saying 55 because this is cell tower range, but industrial automation things may need to be working even at that level, right? So we need to make sure the software that we develop does work in all those kinds of scenarios. So keep this in mind. And so if we are talking about open source development projects that support mobile communication, what are the big things that are going on in the world, right? As I said, there are, I don't know, million projects in the world that are open source, so we can't go through every one of them. But I want to give you a taste of some huge, big open source projects that are ongoing. You can get involved in it today. So the first one we'll touch upon is Open RAN. I usually create the slides and then talk about it myself for most of my lectures. But in this case, I thought I'll actually take you to the websites and show you pieces of it so you immediately develop a sense of familiarity. So you can explore it offline, see if it is of interest to you, and become a contributor, right? Or get involved in however way that you see fit. So Open RAN, this stands for Radio Access Network. So this is a huge project that is ongoing. And then there is Data Plane Development Kit, DPDK, is another huge project. This is their website, right? Originally, DPDK was initiated by Intel. We will talk about it. What is it that they do and where the status is, etc. a little bit. But this is not an Intel only project or anything like that, right? So this is this was initiated by Intel, but now it's an open source project, and our complete competitors, AMD or NVIDIA, ARM, they are all contributing to Data Plane Development Kit, right? And you can contribute too. So we'll dive into it to see what is it that they were trying to achieve. Then there is this Open Data Plane, ODP, is another project. This is again much more focused on the communications business. My team was particularly involved in this one open source project called Event Machine. So Open Event Machine, OEM, as a project originally started by Nokia. So my team was contributing a lot to this particular project. But then this was mainly used by Nokia itself. It is an open source project, but it remained more or less a Nokia project, and Nokia was the only one using it. And so this eventually morphed into this other project called Open Data Plane, ODP, which is what is more active at this point, even though I'm 100% sure most of the phone calls that you made at some point or the other in your life did go through this Event Machine, because Nokia cell tower equipment is all over the world, including many places in India. So it might have touched our code in some shape or form, which is nice to say. But and so this is running currently, and they are deploying 5G equipment also using this Event Machine concept. But if you go into opendataplane.org, you can see what is active, where more companies are contributing, and how it's thriving. Then these are all mobile communication projects. And then OpenVINO is an Intel initiated project. This is still mostly Intel supported, because we develop and then put in a lot of code in there. But this is open source, right? So anybody can contribute. You can see the code, you can download, you can use it. And this is mainly focused towards machine learning and AI. And some of this again is used in mobile communication also. You can imagine from the 5G lecture, or even from other point of view, ML, AI is coming everywhere. So definitely it's going to influence mobile communication as well, right? So what's being done here is being utilized in mobile communication projects also. But if you go into OpenVINO and then look at it, you will see, in addition to mobile communication, be it image recognition, be it large language model training, be it any small individual laptop PC level machine learning training that you want to do. OpenVINO supports those kinds of projects as well, right? So we will touch upon that as well. So first one we talk about is Open RAN that's out there. The idea here is to develop open source code with very open source standards, specifications that are developed, on which vendors can start building mobile networks, right? So this is the idea is not to completely lock everybody into proprietary hardware and software, but make it all open, so that what they call COTS, COTS, that stands for commercial off-the-shelf equipment, be it servers, be it NIC card, be it the memory chips, whatever it may be, all the commercial standardized hardware, nothing too specific for custom built for a particular company, anything like that. Using this ORAN software, how can you develop the entire network that will work across and provide you the whole end-to-end communication solution, right? So that is the underlying idea behind ORAN. You can simply go to o-ran.org and you will see a lot of information in there. So I did pick up that website. So I want to show you a short video at this point from that website. So that will tell you how they work, what they do. Let's play that one now. So this is the website, oran.org. If you go in here, you will immediately see this ORAN specification. So even in the previous talk that I gave, I really talked about how important developing standards and specifications are, right? So you can go in and look at that, and there are not one or two, but dozens and dozens of specifications that are discussed that are put out as ORAN standards. So if a vendor comes in saying, hey, we are completely compatible with this particular ORAN specification, then they will be able to interoperate with other vendors that are making equipment. So somebody may be making the cell tower equipment, somebody may be making the core equipment, somebody making the antenna that goes in. If they are all matching the ORAN specs that are being put out, then they all can interoperate really easily, right? And so in the 5G talk, we particularly talked about slicing architecture, where we actually slice the network into different layers. And so maybe one top layer may be extremely expensive, but provides you ultra low latency and reliable communication. Whereas all the way down, it may be very cheap, but it provides just best effort communication for somebody to browse the web, right? Those kind of slicing that we talked about. You can see there is a separate specification just for defining the slicing architecture. And this is all open source, right? So it's part of the ORAN Alliance. And once somebody develops this, there are trials going on all over the world. And there are also what are called Plug Fest going on. Plug Fest means you bring your equipment to a particular location over a period of, 2-3 days, and then plug the things each other with one another, right? So maybe there is a cell tower equipment, cell tower antenna, etc. So you plug the two together to see, hey, you said you completely follow the spec. You said you are following the spec. So this should be able to work with each other. Is it working with each other? If yes, then ORAN will give you like a check mark saying it's been verified, it's working. And so company ABC may be making the antenna equipment, and company XYZ may be making cell tower equipment. Then a service provider, if you are like Reliance or Vodafone, you can go and look at various features they offer, but you can be confident that you can take company B's antenna and then company X's equipment, connect them together, and they'll all work okay, right? So that's the purpose of PlugFest. So let's just look at a short video that tells you what is it that they do and how is their whole process working. So this gives you an overall idea of this ORAN alliance.
Transforming radio access networks to be open, intelligent, virtualized, and fully interoperable is not a far-off vision. The O-RAN Alliance has made this vision real. Since 2018, the adoption of the O-RAN Alliance by the industry has been incredible. It has grown to a worldwide community of operators, vendors, and research and academic institutions jointly developing a sustainable O-RAN ecosystem. Through expanding traditional mobile networks, the O-RAN Alliance has created its O-RAN architecture to become a foundation for truly open and intelligent radio access networks. The O-RAN architecture improves the RAN in several areas. First, the O-RAN architecture supports disaggregation of software from the hardware and network virtualization. Underlying open reference design hardware and the O-Cloud provide a high-performing and scalable computation layer. Second, the O-RAN architecture is based on well-defined open interfaces to enable a multi-vendor, interoperable supply chain ecosystem. Third, the O-RAN architecture empowers mobile networks through artificial intelligence and machine learning. O-RAN networks can self-optimize to ensure the best possible service for the end customers, and automated operations and maintenance enable more efficient network rollout and operations. Defining the complex O-RAN architecture is a step-by-step process, resulting in hundreds of technical documents. To ensure compatibility and to avoid duplication of work, the O-RAN specification effort builds on common standards and cares about alignment with other industry bodies. O-RAN specifications serve as a basis for open software reference design. The O-RAN software community hosts developers brought in by many O-RAN players, cooperating on tens of software projects. O-RAN specifications in open software are enabling a broad industry ecosystem. Companies of different sizes and competencies can use them to create their innovative and competitive open solutions. In addition to specifications, O-RAN Alliance supports the ecosystem in testing and integration. O-RAN Global PlugFests allow companies to demonstrate component functionality as well as multi-vendor interoperability. Moreover, the open testing and integration centers around the world will offer a collaborative and impartial testing environment. O-RAN supports implementations using open source modules, proprietary modules, or any combination. Operators and suppliers can create different paths and approaches to implementing O-RAN, optimized for their specific network and customer needs. The rapidly emerging O-RAN ecosystem has enabled service providers on multiple continents to start field trials and commercial deployments, aiming to build significant parts of their networks based on O-RAN technology. Open, intelligent, virtualized, and fully interoperable, O-RAN-powered mobile networks will soon be serving billions of people around the world. The O-RAN Alliance.
Hope the audio came through well, and hope it makes sense, right? So this is, again, this is not just an Intel specific thing to promote or anything like that. This is an open alliance, and you might have seen in one of the slides they showed how many companies and people are involved in. So you can just go to this website and then start digging around. You will see, for example, if you go into the specification, there are tons of specifications that you can go into. It's not just one. That slicing one that I showed you is just one, right? So you can see so many companies involved. And this map actually shows you what are the areas in which there are O-RAN trials going on, or PlugFest going on, meetings going on, and so forth. And that includes India also. right? So there is Airtel, Vodafone are deploying ORAN-based equipment that is starting to function, and you can see it spread like all over the world. So let me go back to the slide. I hope that gives you a general sense. Again, you can dive in, you can actually get involved, learn about it, download code and play with it. You can contribute, all that is possible. Of course, this is for a much bigger, huge project. So not for somebody to do something at home, meaning the actual code that you don't download and run it at home, but it's more for equipment vendors to download and then develop interoperable equipment that provide 5G mobile communication thing, right? So this is one. So let's dive into one more. So DPDK stands for Data Plane Development Kit. So as I said, this is actually a project that was originally initiated by Intel, but it's no longer purely Intel. Just initiated, we funded, we contributed a lot, we let it grow, and then now it's become an independent organization to which everybody, including our competitors, do contribute. They do make 2 releases each year, and one will be in the March timeframe, and then one will be in the November timeframe. And usually the release version number is referenced by the 2-digit year, so 2024, and then the 2-digit month, 03. So this means this is the latest release that was made last month, right? So you can see it's a very active project. So you will see 23.11 as the previous release, 23.03 has the last March release, and so forth. So they are extremely rigid. So they make 2 releases. These are all huge projects, right? So it need to be managed well. And so there are like very clear windows in which you need to submit your code, when it needs to get reviewed to make it into a particular release. Whereas if you and I are starting our own small open source project, you can probably make releases every day or 2 times a day, whatever. Like, so all these models are possible. But once the project becomes really big, they try to become very regimented, very process oriented, so that it can some sanity can be maintained, right? So every 6 months you will see a whole bunch of new features, a lot of code changes coming in to get these things working. So what is DPDK? So let's dive into it a little bit more. If you go into YouTube, you can see lot of lectures that talk a lot about DPDK. What is it? How does it work? And we can talk about just this one topic for a week. But I just wanted to give you just a quick overview idea, right? So this is to expose you to different kinds of open source projects that are out there. Then you can go explore and find out what interests you. So as I said, Intel contributes a lot. So whatever chips that we put out, Xeon are our huge, massive, extremely powerful data center type chips. Xeon D is usually used in mobile communication, cell tower. So it's powerful, but still it's more power optimized with like Atom cores and so forth. Then this Atom and Intel Core, these are smaller laptop kind of powering devices. Then there are all these GPU, IPU, this is infrastructure processing unit. And we deliver a lot of Ethernet chips and content cards. And this quick assist technology is one of the accelerators that we have in the Xeon devices. And there are all kinds of FPGA and so forth. So all kinds of things that Intel does, we try to develop DPDK support for it, so people can actually go use it. And you can see all our other customers, competitors, partners, they all contribute. ARM, NVIDIA, AMD, they all contribute to it. And it does support all these open source ecosystem, Red Hat or Ubuntu, etc., that we mentioned. And then commercially proven, meaning Huawei, ZTE, Cisco, you can see these are all huge equipment manufacturers, Ericsson, they all use DPDK, right? So now what is DPDK? It's can be easily briefly defined as It's a set of software libraries and drivers for accelerating packet processing workloads in carts that's commercially off-the-shelf hardware that's easily available, right? So you don't need any specific kind of hardware, but you can just buy what's available in the store, and it will be able to run DPDK. So what is it exactly? So the idea is, previously, for everything, take off a router at your home. You are trying to build a firewall, whatever it may be. So for each thing, there had to be like custom built devices. Of course, there is some value in it, and that is one approach. And we talked about in the packet processing lecture, the advantages and how the pendulum swings back and forth. So on one side, you have the previous versions where there is an extremely custom built devices that are supposed to do just one thing only, right? But then, as we talked about in that lecture, then we added some CPU capacity, so you can do both a little bit. And then on the other end, you have pure CPUs that can do anything you want, but it can't do it as well as the custom built versions, right? So there are this range of options that are available to you. And so instead of that, how can we speed packet processing so that things can get done much faster? It may not be appropriate for every case. So for example, all our customers do not use DPDK, but many do, right? So wherever it is possible, if you can implement your solution using off-the-shelf chips, then it's cheaper. And if you can use open source software, it's cheaper. So you can get to market faster with a cheaper solution if the solution is adequate to serve the needs that you are trying to serve, right? If you particularly have a specific need and it's extremely high demanding, etc., then it makes sense for you to spend the time, work with us or work with other companies to develop specific chip, proprietary software, and so forth. But a lot of things can be done with commodity hardware, open source software. So can we make it open standard and then make it all work continuously? So that's how this whole idea started. And particularly DPDK, as the name says, data plane. So we are not talking about control plane, which means the CPU is involved in doing whatever that you need to process. But it's more like data plane, meaning that ton of packets that are just flowing through the device. How do you speed that up, right? So that was the question. And again, if you had attended that packet processing lecture, you might remember there are specific hardware designed to just look up an address and then forward it to a particular port and things like that. If it's all there, fantastic, great. But if it's not there, then what do? You just run software to do all that functionality, and it's not really performing that very well, right? So why is it not performing that very well? So this chart, in a very easy to grasp way, shows you what is going on. So look at this. This is the packet size. So it's just 64 byte packet. And then you keep going all the way. And this is about 1200 byte packet, which is the standard server Ethernet kind of packet. And then it continues to go. It can go up to 64K byte packet, right? So we take 100 gigabit per second line rate, meaning you have a pipe that's bringing in 100 gigabits per second. And everything in that 100 gigabit is all 64 byte packet, okay? If that happens, so how many packets are you going to get every second? If you look at that, basically you take that 100 gig and then divide that by 64 byte, and then you get 100 gig packets per second. So the packet arrival rate, it turns to be extremely high, right? So this is like 148 million packets that's coming through each, because each packet is so small, it's just like flooding in. And the packet arrival rate, meaning if you're just serially receiving each packet, you get only 6.7 nanosecond to pick up each packet to process that, right? And then let's say your CPU is running at 3 gigahertz clock cycle. That means it will give you about 20 cycles to process that packet, right? Because that's all the time you have in 6.7 nanosecond, because the next packet is in, you need to process that. But as you keep going, the packet size becomes bigger and bigger. Then, of course, the number of packets really drops, right? So instead of 148, you get only 12 million packets if it's like about 1200 byte size. So you can see instead of 6.7 nanosecond, you get 83 nanoseconds. So you have a lot more time here. At the same 3 gigahertz CPU, you get 251 cycles per packet. So you have a lot more time. You have enough capacity. Unfortunately, when it comes to mobile communication, a lot of packets tend to be really small, right? Voice packets are all very small. Only then you can maintain continuity and then quality of the call, etc. You can't put huge packets and ship it once in a while. So what happens? People take the Intel or some standard CPU, they just write some code saying, okay, receive the packet, look at it, process it, send it off. Then receive the packet, look at it, process it, send it off. And then they just run it. Whatever capacity you throw at it, it's not able to keep up, right? So they simply run it and it's not able to manage the load. The voice quality is so bad. So what do? So initially it looked like, oh, nothing can be done. This is so bad. And so you do need to go to this special purpose hardware that we need to build, right? But again, if it's an extremely high-end, high revenue generating particular application, it makes sense to do that. And we still continue to support and do that. But what if it's a smaller, kind of cheaper option that you want to provide? You don't need that high end, you can't spend that much money, and you want to go to market much faster. So Intel thought about it. Then we came up with this DPDK idea to see, hey, what are all the things that we can do so that we can improve this packet processing in the data plane, right? That's how DPDK actually got initialized. So this is extremely useful for mobile communication, but this is in general, this is how things actually work. So when packets come in, this NIC is network interconnect interface, basically the network card through which packet comes in. So there is this big Linux kernel space that is sitting there that does a lot of work in like receiving. So there is a driver, as I mentioned before, and then there is the kernel stack, and then there are system calls made. And from the NIC card, the packet gets copied over to the kernel space. And then the kernel says, okay, I got a packet, so let me give this to you. And then it gives that to the user space. So there is a packet copy happening. And then the packet data is available in the memory space for the user space application to look at it and then process, right? And then again, if you want to send it off, you may need to copy it back, and then the kernel needs to copy it over to the NIC card and then send it out. This is just the standard way in which the Linux networking stack worked, right? So the kernel provided a lot of services using which it receives the packets and hands it over to the user space, receives it and sends it off. So that's how it works. And on top of that, there will also be things like the NIC interface. Whenever it has a new packet, it will interrupt the kernel service saying, hey, there is a packet. And then the kernel goes and picks it up, right? So that's an interrupt service routine, ISR, that triggers to tell the system that, hey, there is a packet, hey, there is a packet, right? But all this takes time. Anytime you need to copy a packet, it's a disaster. It takes a lot of time, right? And anytime there are so many small packets coming in, you are handling all this in the kernel space and managing this and then handing it over. There are a flood of packets coming in, and so disaster. It's disaster meaning it's basically how much you can handle becomes really difficult, and the bottlenecks starts to form. So what DPDK proposed is bypass this whole kernel space as much as possible, avoid the copying process, and hand over the packet to the application directly, right? So that's the main thing that came in. You can go to the web and read a lot more about it. So we basically set up a path from the NIC to the application, and we also have developed using this what's called PMD, meaning pole mode driver. So instead of anytime there is a packet and this getting an interrupt saying, hey, there is a packet, instead of that, we actually do it from the other direction, saying poll mode, meaning you constantly keep polling, saying, hey, do you have a packet? 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 Right? So you continuously keep doing that. If you do that, anytime there is a packet, instantly it gets picked up, grabbed, and then goes up. And in addition to that, instead of just for each packet sending an interrupt saying, hey, there is a packet, whenever the poll mode happens, it not only goes and says, do you have a packet? And if there is not just one, if there is a bunch of packets, it will grab them all together, right? So we routinely do 32 or 64 packets, we grab them together and take it up. So that actually reduces the amount of computation that you need to do to generate the interrupt, to do the polling, this and that, all that. So all this improves the efficiency with which you can do this packet transfer to the user space, right? So DPDK bypasses the kernel stack and the driver, and then it does zero copy. So since the memory is also made directly accessible to the user space, there is, you can see, I mean, this red one and then this copying, that is eliminated. You directly put the memory in, I mean, the packet in the memory where the application can just work on it. You simply eliminate packet copying, you make things run much, much, much faster, right? If this is the case, why shouldn't we be doing it all the time? Of course, if you generally make this the model, it just introduce some security holes and there are issues. So this cannot be happening everywhere. That's why there is the kernel user space, all that was traditionally built in. But there are a lot of things that have gone in to make sure this is still secure. You can develop an application, you can still run it on top of it, and things will be safe, etc. Right? So these are the main things that we are solving. So the high performance challenges. The first one, the system can't keep up with the number of interrupts for the packet. As I said, hey, there is a packet, we have removed that, right? So you are basically saying, hey, do you have a packet for me? Do you have a packet for me? So by doing that, this interrupt thing is totally removed, and we use the PMD, pole mode driver, that picks up as many packets, just grab them as quickly as possible. The Linux scheduler causes too much overhead for task switches, right? Normally, the Linux kernel is like a manager sitting there and then looking at all the cores that are there saying, okay, you do this, etc. So packets may be coming in, but it's like one manager. It's like overwhelmed and he's not able to keep track of all the things that are there. To avoid this problem, we directly connect one particular core to do this idea of just picking up the packets. This is not normal, right? So this is a DPDK version. When you have a lot of cores, you can afford to specify one or two core or even a bunch of cores just to pick up these packets so that the Linux kernel is removed from this responsibility. It improves a lot. So again, this is for massive systems, a lot of packets coming in. There it makes sense to do it this way. So this was not originally in Linux, so we brought this idea in. Memory and PCI access is really slow compared to CPU operation. So this is why I said we process a bunch of packets picking it up. So the cost gets amortized, meaning it gets divided upon the bunch of packets that you took. So if grabbing a packet takes whatever nanosecond, now you are grabbing 32 or 64 at a time because this is a flood of packet coming in. That's what we are trying to solve, right? So the cost becomes 132 or 164 of the original cost. So that speeds things up. Data doesn't seem to be near the CPU when it needs to be. So we move this, that's why we are saying this prefetching, meaning expecting what is needed, we start to prefetch that. Access to shared data, it's a bottleneck, meaning usually when packets come in, there is also like locks put in around the memory so that different cores don't start grabbing stuff at the same time, corrupting the memory, right? That takes a lot of time. So you need to, it's like you have a godown or a warehouse where you have stuff, and then there is like only one lock and key. So if somebody wants to go in, you take the key, go in, open the lock, pick your stuff, lock the key, come back, put the key here. And then the next person goes, opens, and then takes it, comes back. We totally removed that. And instead of that, we set up a ring buffer. There's a start point, end point. So we keep picking stuff up continuously, and then we keep adding stuff to it completely. And of course, if these two come to a same point, things will stop, but we try to make it big enough so that these two can just keep going continuously. And by isolating the cores separately, we make sure that there are not two cores going in and corrupting the memory, etc. Right? I hope I'm trying to say too many things because DPDK is a huge project. We can talk about it for a week, but I just wanted to give you a sense of what's going on. So basically, removing that lock and key, people can just stream in and then pick up stuff really fast. Remove a lot of bottleneck from there. And then there are even things like there's a notion called this huge page. Within the Linux kernel, the memory space is normally defined as 4 KB, kilobytes of space. So if you have a huge packet that's coming in, you need to put that in multiple pages, right? So it's like you have some huge thing that came in, you need to cut it up and then put it in multiple mailboxes kind of thing, and then you need to pick all those one by one. Instead of that, introduce this huge page concept where instead of 4 KB, you introduced like 2 megabytes and even up to 1 gigabyte size slots in which you can put stuff in. And so you can see instead of 4 KB, if you have 2 MB size, you can put much larger packets in there so that things can work much faster, right? Again, if you ask why are we not doing it everywhere, it doesn't make sense to do it everywhere because often you may not have that much traffic coming in. You may not be able to allocate a code to do this all by yourself, etc., etc. So it doesn't work everywhere. But in cases where the customers wanted to improve the data packet throughput in the data plane, all these changes made a lot of sense, right? So we introduced that. And you can go up and read a lot more about it. So there are like core libraries and how things work and what happens. But you can see from the previous slide, by making these big changes, we can tremendously improve the amount of packet that gets processed through the system, right? So that's another big invention that came through DPDK. Again, you can just go join the DPDK project, start contributing, reviewing, all that is completely possible. And this is the other one that I wanted to mention. This is that open data plane. So this is another project that's open source. You can get involved if you actually go down and see immediately. We'll talk about how you can get involved and where you can download, etc. The idea here is there is a concept of how packets come in, how packets go out. In case of the Intel-like companies, we come up with our own hardware acceleration, like we talked about the DLB, right? That improves the performance of packet processing. But the idea behind this open source project, Open Data Plane, is for the vendor to completely hide all the hardware-based solution that they have come up with and then expose their chip only as a standard set of APIs using which the application can still use the chip, right? I hope what I'm saying makes sense. So maybe in case of mobile communication, you may want to say, set up a call, set up the channel, tear down the channel, etc., right? If you have these 2-3 calls using which you develop a phone application, set up a call, set up the channel, and then tear it down, etc. If you don't have to worry about how it gets done below, whether it is pure software that implements it, or is it because we introduce this DLB kind of some sort of an accelerator that is making it run much faster. If you remember, even in the talk, we said the end user need to understand what is going on, how does this thing work, etc. If you can eliminate all that and then make it all look seamless, you still expose only 3 things. So if there is a pure software solution, you implement everything using pure software. If it's hardware involved, you still implement it using hardware to speed things up. But for the application developer, it always looks like the same 3 calls that they need to make, right? That's the overall idea behind this. open data plane. You're opening up the data plane, hiding how things gets done beneath from the user, so they don't need to worry about it, right? So this is another project you can take a look at. And so we won't go into all the details, but it gives you an idea of, first, we know about Linux. We talked about ORAN, and we talked about DPDK. This open data plane is another mobile communication related project. So you can go take a look at any of these. Then we'll look at just one more before we close out, right? So OpenVINO is one more open source project. Again, the source code is available. You can contribute, you can go, you can download, you can use it. And I'm bringing this in mainly because this is AI ML related. So that's a hot item. So Intel is really involved in. And on top of that, this can really work on your individual laptop or PC. You can download the OpenVINO stack and then run it on your laptop to see how things work, right? So this is something that an individual user can use, but it is still useful because it's machine learning. It is also useful for mobile communication, right? So you can go to this docs OpenVINO AI. You can see it's in the AI domain because it's really involved in OpenAI. So let me play one quick video that talks about what is OpenVINO. So it's basically a software stack that we will give. You can use it to do image recognition, large language model. You can download and install it on your laptop and run it and so forth. So let me just play this for you.
Welcome to an introduction to OpenVINO. I'm Raymond. I'm an AI software evangelist from Intel. In this video, you'll learn about OpenVINO, what it comes with, how it works, its benefits in model performance optimization and deployment. OpenVINO is an open source toolkit from Intel. We started with computer vision model support, and now we have expanded to natural language processing, audio, and auto-generative AI models. We know creating AI solutions can be complex and time-consuming. To solve this, we made OpenVINO the inference API of choice. It lets you drop a pre-trained and optimized AI model into your application to make quicker predictions and decisions. You can build, deploy, and optimize your solution across a wide variety of hardware and platforms to help enable speed and performance out of the box. It's fast, it's easy to work with, and it gives you freedom of choice. When you start, you can choose to bring your own model or easily use a pre-trained model from popular frameworks. And for TensorFlow and PyTorch users, your models get automatically imported and converted. For optimization, preparing models takes fewer steps and code changes. This means less development work for you. But OpenVINO also gives you granular control. If you're looking to optimize further, you can use the additional compression techniques available. For example, quantization allows you to reduce the precision of the model with minimal impact to accuracy. This helps to save computational and memory resources to achieve faster inference. When in deployment, OpenVINO Model Server is available as an option that lets you efficiently deploy your model on a wide range of hardware using a common API Kserve. You can easily drop in an inference acceleration without rewriting code. No matter what industry you're in, OpenVINO can help you develop and optimize your AI solutions at scale. The use cases are endless. You can speed up self-checkout at retail, denoise audio capability for video conferencing, translate and synthesize speech simultaneously, or even generate code itself in development. OpenVINO Toolkit gives you the flexibility to make your AI solution a reality. To keep learning, we have a wide variety of resources for you to get started and dive into. Thanks for watching.
Okay, so I won't dive into it anymore, but you can just go look it up. Just OpenVINO. That's a AI ML solution that Intel is offering, right? So then we need to touch upon this different kinds of licenses. At least I want to sensitize you to what's available. So when you talk about open source, once you develop code, once you put it out on the web, what is it that people can do with it? It gets really complicated, right? So at one end, you can just say, hey, I gave it, you do whatever you want, and anybody can do anything with it. So that could be one model. But there are different license versions in which different kinds of permissions are given or not given that at least you should be aware of. So one of the most popular license version is called GPL. You might have heard this term. It stands for GNU Public License. So this is usually referred to as copy left. instead of copyright, copyleft. So what it means is there is a code that's given to you. You can derive or develop or enhance or add to that code, and whatever new code that you develop inherits the same license that was on the original code, right? So if the original code said you can freely distribute and add whatever you want, the same thing applies to this one also. So that's called this copy left model. This may look like, isn't that what open source is? No, not really. I mean, there are a lot of different variations, right? So there is one called Apache license. So here it says you need to include the copyright licenses of the original code. If you notice that, I mean, that wasn't there. So here, if the original thing said that, then it applies to the new code also. But here, by default, you need to include the copyright license of the original code in the new code that you develop. And then derived work can use different license. So if you notice here, it said any new code must use the same license. Here it says it can use different kind of license. So you can take one Apache license code, make some changes or add it, and then change the license when you ship it out or when you put it out on the web for somebody else to use. And it includes patent grant, which means if some code that has some patent involved in it, anybody that is using it will not be sued. I mean, they are not violating any patent because the patent is granted along with it, right? And then there is a thing called MIT license. This is, again, need to include the copyright like this, the top one, but any use modification of the original code is allowed. So you can completely change the original code itself and ship it out, but this does not give you any patent grant. So whoever originally owns the patent, they still continue to own it. And so they may say, hey, you can take this code, but if you really use it, I want $1 each time this you ship a product or something like that, right? So that's possible. Then there is this BSD license. So this, again, need to include the copyright license of original code, but allows larger or licensed works to be distributed without source code. So you can ship the binary version for people to use under different license terms. So initially, when you look at it for the first time, it may look confusing. There is a lot of details to it. So in fact, I looked around, is there a simple way to show what are all the different combinations? So came across this sync, this particular website had this table. Again, you don't need to memorize it. I just want to sensitize you to the idea that there are so many different kinds of licensing that's out there. But in general, there is this copy left model, which means whatever you get, the same license applies to the new code that's developed. If it's all free, this is all free and you need to ship it out. If the source code is visible, you need to make the source code visible and ship it out. Whereas there is this other kind called permissive, meaning it permits you to do whatever you want. And so it's not so strict as copyleft, right? So in that case, you can take some code, but then you can sell it. You can take some code, make a modification, and then put a different license in it and sell it. So there is this two broad kind. I'll provide these links so you can go look at it, and then individually, do you support patent use? Well, is the source need to be disclosed? It's yes here, no there, and license and copyright notice, do we need to include blah, blah, blah. All these variations are all there. Right? And if you find this area interesting, this may sound a bit too geeky, but intellectual property and how these things are handled is becoming a big domain. So potentially some of you can even become an IP attorney, lawyer. So there is an interesting free book. I'll provide this link also. It's Law for Computer Scientists, right? So I'm reading through this book. Interesting. It's not specific to US or Europe or India, anything like that. It's generally about law and computer science and how licenses and how these permissions work, etc. So as computer scientists, as we grow, it would be a good idea to be at least aware of all these variations that are out there, right? So we've been talking for 1.5 hours about all the great things open source model does. Are there any downsides? Yes, there are, right? So the first thing that I have struggled with is we don't have any control over the timeline, meaning let's say Intel wants to launch a particular product on whatever, July 31st, right? Can we make sure all the open source support is all there before that time? If it's a much more control, if it's OpenVINO kind of thing where we are making all the contributions and making a release, yes, that's possible. But if it's something like Linux Foundation, we do need to submit the code maybe 2 years ahead, train them, get them all approved, and bring them out at the right point. And they simply don't care whether you are Intel or some an individual person submitting it, right? So their focus and orientation, what they want to ensure, that's all very different from what our interest may be. So we totally lose control, right? So there are like this DLB that I talked about. My team has been trying to get the driver code out there. It's not been accepted, and so we still provide that as out of tree. So that is that one issue that we should be sort of aware of. And then if you really go in and look at it, some will say from like control, training, security, stability, community point of view, either open source is good because it's all open, everybody can look at it. If there is some security hole, somebody will come and fix it really quick, etc. Or some may argue because it's all open, somebody can mess with it and then put out something that may be vulnerable, whereas if it's like closed source, it's much more controlled, etc. Right? So that is something to pay attention to. So the notions become different. There is potential for malevolent hacking. So there are, in fact, you should actually go and check out a couple of cases. So University of Minnesota researchers wanted to show that open source is not safe. So they intentionally tried to introduce some vulnerability as a source code submission, but they got caught. And as a result, there is a big brouhaha. You can go read about it on the web. And the Linux Foundation moderators totally banned the University of Minnesota submissions from being accepted into Linux, and so they are still kind of negotiating. So, but there is always a potential. If it's a huge Linux kind of organization, maybe there are tens of thousands of people looking at the code, so things may not go bad. But if it's a smaller project, there is a possibility that some malevolent code gets put in, right? So there are also like state actors can potentially get in. If there is a adversarial country, they really invest a lot and they got extremely sophisticated software developers submitting some code that will give a opening to that government or something. That's possible, right? So we don't know. Since the code is all open, you can see what's going on, but now the code has become so complex, it may be difficult. So that's something to keep in mind. Projects may get cancelled. So you can go look up this Thorium project. In each one of these lectures I give, I also learn a lot because I need to go read up and make sure I know what I'm talking about. So when I was doing research for this course, came across this. So somebody started a small project called Thorium. It's a web browser project. Worked really well. People are supporting it and hyping about it. But then that person's personal political beliefs started leaking into this project. It really went haywire and everybody hated it, and then the project just stopped. So if you have started using it, maybe the project stops and you may not have any support, and there is nobody you can go sue, or there is no company standing behind it, etc. But as a result, there are also interesting models that come up. So for example, Red Hat is a company that provides Red Hat Enterprise Linux. But the Red Hat Linux, you can download and use it. It's for free. But if you want support and service, then you need to pay a subscription fee or a fee to Red Hat, right? So those kinds of models are there. So you can talk to them. Somebody will really help you and so forth. There are, of course, if a company just thinks by putting out their code in the web, expecting the public domain people will take care of it so they can just save development engineers' salary, that doesn't really work that very well, right? So either the project starts to die, or you get all kinds of wrong code, or it gets pulled in different directions, etc. But if it's very well handled, companies can make a ton of money. So Red Hat is an extremely profitable company. Android may be an open source project, but Google is an extremely well profitable company that's out there. So there are companies that really profit from open source project, right? And one other thing is often you will find too many options that might be confusing. So if you just go and tell your family, hey, open source is fantastic, you should use Linux. If they just ask which Linux, even that can get confusing because there are 100 different distributions out there, right? So which one do you use, which is well supported? That can get a bit confusing. So what are the final takeaways at this point? So open source model, it certainly is a powerful force that's reshaping the world of computing, not just mobile computing, whether it's AI, ML, security, whatever you can think of. There's a lot of open source work that goes on. It's easy to get involved. So you don't need to go through an interview. You don't need to get a job, right? So you can just start looking at what's available, get involved, learn about it, start providing review comments, build your credibility, and you can really get in there. And there are jobs, right? So there are so many different types of projects to choose from. DPDK is like something that I mentioned, Linux kernel, etc. And they do offer fully paid, high-end permanent jobs that people can do. For example, just for Linux Foundation, companies like Intel pay $100,000 annual membership to support the project going and so forth. So many of the projects are rich, they employ full-time personnel and so forth, even though it's open source. And we are not at the end, meaning you can build your career, you can create your own small project. If it takes off, that could be a good profitable model, lifetime career choice for you, or you can join any of the existing projects as a hobby that can turn into a career, or it need not become a career. You can be part of a regular company and still be involved in what you are interested in. Right? So those are my final takeaways. That was my last slide, and I'll stop here and take any questions if you have. Looking for.
Yes, sir. It was really interesting talk. Covering from the open source, relating it to the communication was the key thing. Because whenever it comes as open source, it's like more towards computer science development, and students realizing that even communication you require open source development was really thought-provoking. Thank you, sir. Thanks a lot for such a wonderful session.
Yeah, even in the hardware side, right? I'm sure you are all familiar with RISC, RISC.
Yes, sir.
Reduced instruction set computing. RISC-V is it's an open source thing, so it's there. And if you really go dig into it, you can find hardware designs, chip designs, everything being open sourced as well. Of course, it's not as big as software because it's much more involved and more of a nascent new idea that's not become huge yet. But even like the book that I talked about, I will send the links to Dr. JV.
Sure, sir.
Those are all copyleft, meaning somebody wrote it, they put it out for the benefit of the society. So you can look at that. So it's on hardware, software, book writing, everything comes in open source.
I think the open source, necessarily not free, is something I think has been made very clear in this talk. So
yes,
generally the understanding is okay.
Understanding
means it's all free. So I think that's one thing, sir. I very much loved the DPDK project personally. Nice, but this whole mode driver is it really does it has challenges? Was something that was bothering me.
Okay. No, my team particularly works on the DLB that I keep talking about, the dynamic load balancing whole mode driver. So my team is responsible for it. If there is a problem, the problem is you basically dedicate a core to do that polling, right? So you constantly keep polling, so that core's capacity is used up in just picking up those packets alone. So if you don't have that much traffic coming in, then you are wasting the core's capacity in just checking, is there a packet? It doesn't make sense. That's why the interrupt model was originally implemented, right? But of of course, in the case of DPDK, we are trying to improve the packet speed, meaning the problem that we are trying to solve is too many packets coming in and we are not able to manage. So in that situation, it makes complete sense to use PMD. But if you don't have that many packets, then it doesn't make sense. Right?
Yeah. Nice, sir. Thank you so much.
Hi, can I interrupt? Am I audible?
Yeah,
Yes,
yes,
sir.
sir.
Yeah. Yeah, thank you. So that was very, very interesting. Again, as Dr. Hemant said, with respect to the communication aspect, I had a question about ORAN. It's a very general question, not a
Sure.
specific one. Because ORAN, they still haven't put out a complete spec yet, I think. That's what I was reading in an article a couple of weeks back. It's going to take time before manufacturers take. Do you think it's like a feasible thing? Like because currently we're looking at final rollout of 5G, like proper 5G, later this decade, by which time, people who have had 5G, I will not name them, but yeah, they're already like matured enough into going into 6G. Is it good for us, India, to kind
Yeah.
of hitch our wagon to ORAN right now rather than to sort of leapfrog? Because
Yeah. You can look at it from multiple angles. One is, of course, it's not going to stop with 5G, and the ORAN need not be thought of as a pure 5G
Component of
only
5G,
solution
yeah.
or anything, right? So, and in fact,
like
even
a
in the
development
5G
ecosystem.
talk, I was kind of trying to say that 5G itself is not like exactly well defined. With this, it's completely done, and after this, it's 6G. This all that will slowly start in the second half of this decade, kind of thing. So if you really look at the individual equipment specification, they all continue over a period of time. So as long as you have compatibility between antenna to cell tower equipment to backend core and this and that, and you put them all together to build a system, it will still work. And to your point, certainly ORAN is fairly a new thing, meaning I think it started in 2018 or so. So it's only like some 6-7 years back, right? So
Reliance is huge.
worked with customers for like 5-6 years to design a chip by the time it goes on to a cell tower. So in the world of mobile communication, from chip design to actual rollout of the service, there may be 5-6 years. And so from that angle, it's still new, it's still young, and so maybe it will pick up. But similar to, let's say, Android or something, open source, since it makes it easy, cheaper, widely available, accessible, it always has the capacity to just ramp up, right? So you still don't see iOS and iPhones may be fantastic, they work very smoothly, etc. But still, it has less than 20% of the market share compared to 80% on the Android side. So there is possibility, but you can never predict the future.
Like, because we are still in India, like, how do we now look at what's next? We are now where we rolled out 4G over 8 years after the US. Now we rolled out 5G like 8 years or 9 years after China, about 3-4 years after the US. So there's like very little the loop between sort of introduction to maturity to sort of obsolete. I won't say obsolescence, but at least like how do we look at the economic benefits of that? Like because by the time we get to mature to look at 5G, the 4G has done so much in terms of just the app ecosystem. So how do we now look at? We're still going to be like at least 5 years behind.
I would probably like, I mean, I have like a lot more respect for the speed with which India is like ramping up. In many areas, it's stunning, right? So I'm sure you know.
UPI.
So I won't be surprised in like few years, India just ramps up and it's somewhere else compared to US or something like that. I'm not just saying it for pandering. If you just look at, I think in the end of the 5G lecture, I was showing a video that's a Cisco promotion that talked about Cisco and Jio joining hands. And before that, in I think 2015, India's data usage was ranked 155th as a nation in the world ranking. And then after Jio, Cisco, that data launch, and you all have like a lot more data access than we do. So now India is number one, right? And US is nowhere near. And even that is like 3-4 year old information. Very recently, I read the mobile payments, the data transaction that
UPI.
is taking place.
Yes,
India is
UPI
number
is.
one now.
UPI is absolutely the winner, and UPI, but UPI actually came out from a sort of technocrat bureaucrat combination, and somewhere in 2010 they decided and they saw that. So the fact that 4G and data and apps came about was actually after UPI was set. So that is a brilliant, no question about it.
Sure.
That's better than anything worldwide. My
Yeah.
thing is also that okay, so we see this ecosystem where we have all these apps which are supported because we have 4G, at least 4G connection
Yes,
speed.
at least 4G.
Um,
Yes.
Yeah.
we are now looking at a case where, okay, what are the use cases for 5G? By the time we get to that, is 5G going to be the technology that we should be investing so much time and money in? And how do we now kind of look through that? That's the sort of question. Technology wise, we have people who are working already on so much of the, so Dr. Hemant and all will know, people are already starting to look at 6G, but so that is the when you say talk about ORAN, sorry, sorry, I'm now going. When you talk about ORAN, the big problem with ORAN is you have so many people at the table that you have so many opinions that it takes so long to sort of finalize which is going to delay it, which means that there's so much sunk cost into something that may not come out for us, right? Like so. Would a proprietary approach. I use Linux. I hate micro. I not, but open source is good. But would that be a sort of the best approach for us?
Yeah.
If we're looking at this.
Very good question, and we can talk another hour on it. But I would say it like this, right? If a country like India says, "Oh, this is good for us because it's cheaper and things are coming in really fast, and we can build on it," that alone can be a big impetus for something like ORAN because the market size is so big, right?
Scale is for us. We've been on scale.
Yeah, and that 5G, 6G, I think of it as every 10 years is like 1G kind of thing, but it's not very precisely laid out as. So I mean, I can imagine a lot of 6G still being implemented with some ORAN specification that's being put out in this decade or even in these years. So it's kind of amorphous. It's kind of overlaps. It's not very precise. So I wouldn't really think of it as investing in 5G when 5G is actually winding up, sort of thing. It's more like newer features, newer specs, newer things that are coming in that may eventually roll into 6G also. And as of now, if somebody says 6G, it just made up, it just slideware, right? Nothing.
So we don't have the brick wall between 5G and 6G as we had in 1G to 2G.
Yeah,
1G to 2G was a brick wall. It was a drastic change between the technology.
Yeah. But so now probably it'll kind of overlap a little bit. And
if you go at millimeter wave 5G, like 27 gigahertz and up, so then we can think.
Yeah. So I wouldn't say it's a total loss or anything like that because these specs will continue to run for a while, and whether ORAN will win or not,
that's a different.
Not really sure, but at least I wanted to sensitize the students to the fact.
Yeah. That is very much
level. There is a huge open source thing going on, right? So at least we can. Thank you all again.
Thank you, sir. Thank you so much.
Thank you, sir.
Thank you so much.
Bye bye.
See you, sir. See you soon.
See you.
A couple of days. Yeah. Bye, sir. Bye bye.